Hello, everybody. My name is Jackson Odell, and today I'm very excited to be able to share with you all the findings that I had with the evolutionary path of the modern human being. I've spent the last 4 years of my life actually studying the anatomy and the kinesiology of the human body, how it moves in relation to its environment. So I was very excited to be able to get the opportunity to be able to um, compare these findings with our ancient ancestors, specifically the Neanderthal. Um, us as humans, we're inherently very curious beings. We're always wondering where we came from, what our situation is, who we are. And so no fossil evolutionary lineage generates more interest than our own. Um, we always want to know what we look like and where we came from. And actually, we can date the earliest human skull back about 300,000 years of what scientists have been able to discover with the skull. And with those the skulls and the skeletons that we find um, in those ancient grounds is that species evolve with their environment. They evolve to meet the demands of their environment. And what we're finding is that humans actually are no exception to that rule at all. Um, so to start with the Neanderthal, our ancient ancestor, we had the question, well, what did they look like? That's actually a very hard question to be able to answer because we actually have not been able to find a complete skeleton of a Neanderthal. We have found actually hundreds, if not thousands, of sites or locations where Neanderthal remains have been discovered. But as you can tell in these pictures, that not a single one of them are complete. They're always missing pieces of their skeleton. And so any representation that we have of the Neanderthals basically just a educated guess of what they look like. What they did was take bits and pieces of all the hundreds of sites that have been found, all the locations that have been found, and they've kind of took the average of all the different bones that were found in the different locations, and from those averages, they were able to find or generate a computer model of what our best representation or our best understanding of what a Neanderthal looks like. And this is what we came up with. As you can see here, it's pretty similar to the modern day human, but there are some dramatic changes. To start with, we have this large chest cavity right here. The bottom of the ribs right here kind of flare out a little bit. And there's not a whole lot of distinction between the hips and the waist of the Neanderthal. Um, and thinking about it, like what's the purpose of having such a large chest, such a voluminous chest cavity? Well, when you think about their environment, what they lived in every day was the ice age. It was frozen tundra, so they had to have this voluminous cage here to be able to maintain their body heat to be able to survive the frozen tundra. Next, we have the very powerful shoulders of the Neanderthal. Very broad, very wide, very thick shoulders, very muscular groups, very large muscle groups in these shoulders, deltoids, latissimus dorsi, trapezius, all the rotator cuff muscles in there, very large muscles, which leads to a very large, stable shoulder joint or shoulder girdle per se. Um, and what we're finding or what we're discovering with the Neanderthals is they're not going to be the type of being that goes up and climbs trees or climbs mountains. They're going to be the ones on the ground carrying and gathering. In fact, that leads us to our next slide. They're hunters and gatherers. They use those large shoulders and large arms to be able to hunt and gather their food. A lot of the fossil remains that were found contained large tools and large spears, as one seen here, carved out of rock and some are out of bone. Um, and so that led us to believe that they were ambush hunters. They didn't hunt by throwing their spears. These spears aren't meant for throwing, and their shoulder doesn't have a lot of range of motion because their large muscle groups kind of impede their range of motion. So they're not able to throw things. So they're able to hide back behind the forest and be able to ambush and jump their prey. Um, and so we can see here that the large muscle groups allows them to thrust their heavy weapons to hunt, and they're able to chip hard material to be able to form these tools out of stone and out of bones. Another thing we're noticing is that they have very large abnormal hands. They have long bones, which means long tendons in there too. And what those long bones and tendons actually do is gives them a very impressive, very powerful grip called the power grip. And that allows them to be able to grip the spears, grip their tools, and allow them to deliver that deadly blow with their large power producing muscles. But what's interesting is that we don't think that there's no evidence showing that they've lost any precision grip either, where they're able to grip a pencil, or like you can see here the precision grip between their index and their thumb with their small rocks to be able to maneuver beads or small fruits and nuts. There's no loss in dexterity because of their long, stiff tendons in there. It gives them that ability to have that dexterity. Next, going down the body, they have very large pelvis. You can see in the picture, it's very wide, very long, and it's kind of rotated anteriorly as well in compared to the modern human pelvic bone as well. So you can see in this picture. Now, the main purpose of the pelvis is to be able to support your body weight. Your body weight and whatever it is that you're carrying. And because the Neanderthals, they are gatherers by nature. That's how they survive, is by gathering their material. They have to be able to support all that weight that they're carrying. So they have that very large pelvis, very stocky. But also we're seeing that they have a large hip joint as well, which allows them to have a larger range of motion, which allows them to be able to walk further distances in fewer steps, conserving energy as they walk their hundreds of miles at a time. And that conserving energy is important because they need to conserve that to be able to survive the harsh climates, the frozen tundra, and to be able to maybe run for their life if they need to if a predator shows up. And speaking of being able to walk those long distances, it's very uneven ground and they have that risk of injury. And so they need to have a large patella in their knee joint to be able to stabilize that knee. But it also serves as a leverage point, allowing them to produce more force as they extend their leg. They're walking through deep snow, they're hiking up hills, they're walking through thick brush, and they need to have that extra leverage. They give them that extra force-producing power at a lower cost. And so now let's compare that all to the modern human. Think about us today. Like, we have a very narrow base or frame compared to the Neanderthal. You see they have that large shoulder joint, but the modern human doesn't have that large shoulder joint. In fact, it's very narrow in comparison, which results to not having large muscle groups either. So think about what could change, could spark that evolutionary change. As you all know, the Ice Age has ended, and with the end of the Ice Age, the environment changed, the landscape changed, climate changes, and the forest that the Neanderthals were using to or for shelter started receding. They were losing that ability to be able to hunt. And so to be able to stay alive, they were required to adapt to that environment. And so instead of being able to thrust their spears, they exchanged their force-producing shoulders into shoulders that had range of motion, so that way they could throw their weapons and be able to hunt their prey at a distance. And so that leads to these smaller arm muscles and joints, give them that range of motion, that flexibility, and that speed because they're a lot lighter limb. Also, you can see here that they have very small chest in comparison as well because they're no longer needing to conserve heat. In fact, as the climate warms up, they're needing to keep their body cool, so they don't need a large chest to do that. And because their upper body is considerably smaller, they're also a larger pelvis as seen here in the Neanderthals. So their pelvises start shrinking, their patellas start to shrink, and their bones become thinner and their muscles become smaller as well in the modern human. Because modern human is meant for speed, for agility, for flexibility, whereas the Neanderthal was meant for force and for power and for surviving the harshest of climates. With the modern human now, we're meant for more of those fine motor skills to be able to communicate with one another with our hands, to be able to build communities, be able to build houses and homes, and to be able to have a lighter, more cost-efficient frame and conserve our energy that way. So as you can see here, every species is vulnerable to evolution, and every species must adapt to their climate and their environment in order to survive. And as we're able to explain here, humans are no exception. Um, as the climate changed, so did the modern human to be able to become more cost efficient, to be more adept, more suitable, more healthy for their environment. Um, Thank you so much for your guys' time. It's been a fun thing to be able to research, and I encourage you guys to read my article to be able to learn a little bit more about the details. And thank you so much for your time.